Hi there, this is Mrs McTaggart and this is actually my third video on indices. Today we're looking at negative powers. Before you watch this, you should already be familiar with multiplying and dividing indices and indices raised to the power and maybe the power 0 as well. So I like to prove the rules that I'm going to teach you rather than just jump in and tell you what the rule is. So on this one, if we follow the rule of division, we knew that when it was dividing indices to subtract the powers. So this could be written as a, let me get my pen, could be written as a to the power 2 take away 3, which is a to the negative 1. Using that rule. Or we could go back to basics and do the whole long way of writing it out. Well, that is a times a for a squared and a times a times a for a cubed. I can cancel 2 out from the top, 2 out from the bottom, which leaves me with an a in the bottom. And remember, there's always a secret number 1, and it leaves me with 1 over a. Now, that's the exact same sum, so it must follow that 1 over a is the same as a to the negative 1. Now, 1 over a has a little secret power of 1 that's not written there. And if you look closely at this rule, the only difference is the thing on the bottom has come up to the top and the power has gone from positive to negative. Now, let me show you another way to prove the same thing. Take a very basic number pattern. I've done this in a previous video using 2 to the power whatever. But if we take this one, this gives us 1000. 10 squared is 100. 10 to the power 1 is just 10. 10 to the power 0 is just 1. This also helps prove the 10 to the power 0 rule as well, because I just keep knocking off a 0. 10 to the power negative 1, oh, if I keep dividing by 10 here, it gives me 0.1, or I could write it as 1/10. 10 to the negative 2 could be 1 over 100. Now 100 can just be written as 10 squared if I'm being fancy. And divide that by 10 again would be written as 1 over 10 cubed. So 1 divided by 1000. So this also proves that if you look at this one, if you've got a negative power, you can just take it below and change it to positive. So a negative 2 can be taken below and written as a positive 2. So here's the rule today, written in kind of formula form. So whenever you have a negative power, negative indices go below the fraction and they turn to positive. They actually just change to the opposite sign. The only thing to watch is it's only the base that moves, only the letter. But the proper word for that is probably the base term that moves, which in this case would be the a, okay? So let's look at some examples, the best way to start to understand what's going on here. So this is a huge part for higher. If any of you ever want to go and do higher maths, you need to be amazing at these, because this is what's called the preparation step in topics that you do at higher. So my first C we're going to write as negative indices. So this is when I'm moving the letters up to the top. So this can be written as x comes to the top. So it really becomes 1x, but remember we never write the number 1. So that becomes x to the power negative 3. It turns from positive to negative. On this one, it's only the y that's going to travel, so the 3 and the 2 stay where they are, and the y will come to the top and turn to negative 2. Now, you might look at this end one and think, oh, that looks a bit different. She's left a negative at the bottom. This is okay. The rule was, so you might have heard me say, is the power comes to the top or goes to the bottom and changes sign. So this minus was deliberate. So when this x comes to the top, this becomes 4x. And the minus 4 turns into positive 4. It's very unlikely you see that, but if you are using the TJ textbook, I know there is one in there that looks a wee bit like that. Okay, in reverse. So what happens in an exam is you do all your index question, you maybe have to do a couple of steps, and then it will say, write your answer using positive indices or positive powers. So pretend you came down and your final answer was a to the negative 3. That wouldn't get you full marks because it's not written using positive indices. So what you have to do is think, right, well, the a goes to the bottom. There's nothing there on the top, so there's, remember, that secret number 1 hidden in front of the a. So this becomes 1 over a cubed. On the second one, the x is going to go below, so the 7 is going to stay put. It's very easy to write 1 over 7, but it's only the base that's moving, which is the x in this case. So this becomes 7 over x cubed again. And I'm sorry, I've done 2 with a cube there. That's a wee bit bad of me. And on the last one, the negative 4 is going to travel, and it's going to come down there and join the 3. So I've got 2 on the top, and then that y to the power negative 4 becomes positive 4. Okay, so it's a really important skill to have on this one and to try and remember it, okay? Right, so some further examples. We've got a division here. Division means you subtract the powers, so you'd have a to the power 3 minus 5, which gives you a to the negative 2. But what I should have said up the top of my screen is leave all your answers using positive indices or positive powers. So we're going to simplify that. This is going to go below and turn to positive 2, so 1 over a squared. On question 2, we're going to do the same, just a wee bit more to it. So 10 divided by 2 is a nice 5. A for the base, and then you've got 2 take away 6, which is negative 4. So this would get you mark 1. And then to write it using positive indices, remember it's only the a that moves, the 5 is going to stay where it is. So it becomes 5 over a, and make that positive 4. So please don't try and go straight from step 1 to the final answer. We want to see your 2 steps, and you've got more chance of getting it right if you just show full working, okay? There's nothing worse than making wee silly mistakes in this question. Okay, number 3, this one doesn't divide so brilliantly, but 8 over 16, we should all hopefully know that goes to 1/2. Your power will be 3 take away 7, which is minus 4. So the 1 is going to be on top, the 2 is already in the bottom, and the a is going to come down and join it and turn to positive 4. So we've got 1 over 2a to the power 4. Okay, let's make it a wee bit harder now. So let's bring in a multiplication one. So we're going to multiply the 2 and the 6, which gives us 12. And then you've got m. Now remember, you're adding the powers here. So what we've really got is minus 3 add minus 2. So collectively that is minus 5. So we've got 12m to the negative 5. And to write that with positive powers, the 12 stays put, the m goes below, and it turns to positive 5. So 12 over m to the power 5. Another one, this is divide. So 8 divided by 2 is 4. Remember, this is a secret power 1. And when we're dividing, we're subtracting the powers. So we've got 1 take away 4, which is minus 3. And to write that positively, you'll take your c below, and it will become c cubed. Yeah. Right, so this one, we're going to do the top line first. So you're going to have m. 6 take away 9 is minus 3. So this is using lots of rules. It's using the multiplying rule where you add the powers. Then it's going to use the dividing rule where you subtract the powers. And then we'll see what ends up with in a wee second. So we've got m to the negative 2 in the bottom. Now, I always like to write the powers at the side for these ones, just in case you get a bit muddled. So we're subtracting. So we've got minus 3, take away minus 2. That turns into a big old plus. So this one gives us m to the minus 1. Remember, the m goes below. There's a secret number 1 in front, so it's 1 over m. And I don't need to write the power 1. It's just 1 over m. And then last question, a good old brackets one. So when you multiply this out, you'll have x, 2 take away 2 is the power 0. And then 2 take away 3. Well, the 3 is going to be there first, sorry. And then you're going to do 2 take away 3 is minus 1. Now to tidy this up, power 0 is always 1. And then this x is going to travel below and become 3 over x. And I'm not going to put in the 1. That's what it would look like, but you don't ever put in the wee power 1. All right. So that's me kind of covered as many examples as I could. Hopefully you've understood this, and all that's left after this is a video on fractional powers. So I hope it's helped. Thanks very much.